Everybody, welcome back to the second part of 5.2, dividing radicals. In the previous video, if you do recall, we multiplied radicals, so what we did was we multiplied the coefficients and then we multiplied the radicands, and the indexes, of course, had to be the same. Well, it's a similar process for dividing. You divide coefficients, and you also divide the radicands, so whatever's underneath the square roots, and obviously the index has to be the same. All right. So let's take a look at dividing monomial radicals. Example 1a, we have 2 root 15 divided by 8 root 3. So what I've done is I've separated them into, obviously the fraction out as the coefficient out front is 2/8, and then the 15 divided by 3 becomes all underneath one root sign, which we did learn when we did exponents, you may recall. Okay, so it's a similar process. It can all be written as a square root. So the 2/8 can be simplified to 1/4, and 15 divided by 3 is 5. So we can write this as 1/4 root 5, or root 5 over 4, or root 5/4. It's up to yourself. Let's look at example B. We have 25 root 15 m to the power of 4, all divided by 5 root 3 m to the power of 4. So the 25 over 5 becomes 25 divided by 5, and I've just written it as 5 up in front. The square root of 15 over 3 becomes square root 5, and because the m's have the same exponent, m to the power of 4 divided m to the power of 4 is just 1. So that's where that did disappear, but that's where it was eliminated because it equals 1. So we end up with 5 root 5. So this whole thing is equivalent to 5 root 5. Let's look at example C. We have the square root of 42t cubed divided by the square root of 6t. So we put everything underneath one square root sign. We create a fraction of the quotient there. 42 divided by 6 we know is 7. And t cubed divided by t is just t squared. Remember, when we're dividing and they have the same base, we subtract exponents. So that's where the 2 comes from. And of course, we can further simplify that. The square root of 7 can't be simplified any further, but the square root of t squared is simply t. So we can write this as the square root of 7t, or t root 7. The next one we have is the square root of 169 divided by 64. So that becomes the square root of 169 over the square root of 64, which equals 13/8. So we can go both ways with this if you wish. Alright? I recognize that the numerator and denominator were both perfect squares, so we separate it like that. So that's another method. We can go the opposite way to make it benefit us to simplify. Now, when we were in class before the break, I briefly mentioned rationalizing a denominator. I did it quickly with you in one of the examples, but now we're going to go into more depth about it. So, in general, fractions should not be left with radicals in the denominator. The technique used to write fractions in another form, we call this rationalizing the denominator. So here is how you rationalize a monomial radical denominator. So basically, if you had 4 divided by root 5, how do we get rid of that root 5? Because we can't simplify that any further. So basically, all you do is you multiply the numerator and the denominator by this, whatever that denominator is, underneath the radical sign, of course. So to get rid of this root 5, I multiply it by root 5, because the root 5 multiplied by root 5 is the square root of 25, which becomes 5. Whatever you do with the numerator, you have to do the denominator, because we can't change the value of this. So we have this square root 5 over square root 5, because that's 1, right? Anything divided by itself is 1, so you're not changing the value, right? So 4 root 5 is the numerator, and the denominator becomes 5, and you're finished. This is called rationalizing the denominator. If you want to check to make sure you're correct, go back to your graphing calculator and do it, and just write it in. 4 divided by the square root of 5. I didn't need that bracket. And I get 1.7888, and then I got 4 square root 5, close your brackets. Oh, don't need that bracket there. I don't think it'll affect it. Then divide the whole thing by 5 and get the the same answer. So that's just a way to check to make sure you rationalize correctly. I won't do that every time, but it's definitely a help there for you. Okay. Let's go back. Let's look at example B. This time we have a binomial over a monomial. It's no big deal. So the denominator is root 3, so we multiply by root 3 because square root of 3 multiplied by the square root of 3 is square root of 9, which is equal to 3. You do the numerator like we did earlier in the multiplying radicals. So 3 root 6 multiplied by root 3 becomes 3 root 18. The 6 and 3 multiply together to give you 18, and 3 stays up front. Same deal. Then you got the minus root 15 times 3 times the square root of 3. That is a typo there. I gotta fix that. That 3 shouldn't be there yet or at all. So I'm gonna fix that now. Alright, I fixed that. You'll notice the 3 is now eliminated. My apologies. So this can be written as the square root of 45 is now written as 3 root 15. So you should be able to do this quickly now. We've done this a number of times. We started in grade 10. We've got a good feel for that now. So the square root of 45 we know can be written as the square root of 9 times 5. And the square root of 9 is 3 root 5. So that's where 3 root 5 is coming into play. And then we get 9 root 2 minus 3 root 5. Divide that by 3. So the 9 divides by the 3 and gives you 3 up front here. And the 3 divided by 3 gives you a 1. And there's your final answer. 3 root 2 minus root 5. And again, if you wanted to check this, just plug the original in on your calculator. Make sure you be careful with the brackets. And plug your final answer in, and you'll see how they are equivalent. Here's one with the cube root. Again, this is an extension. It's not necessary for us, but it is recommended you take a look at the cube root ones as well. Done the exact same way, but instead of the square root, you're doing cube root in C. Okay. And in D, we have 3 square root 24 minus 4 root 5 all over root 8. So we multiply this here as rationalized denominator, root 8 divided by root 8. We get the square root of 64, which is 8, so the denominator becomes 8. And then we just do what we've been doing all along with the numerator. So it's 3 root 24 times root 8. So 8 times 24 is 192. 192, that can be written as the square root of 64 times 3. So that's where this 8 comes into play. 8 root 3 comes from the 192. 40 can be written as 4 times 10, which is going to be 2 root 10. That comes into play here. So we got 3 times 8 is 24 root 3 divided by 8. That's where the 3 root 3 comes into play. And then we got the minus 8 root 10 divided by 8, and that's where the 1 minus, there's no number here. You don't need a 1. You can put it in if you want, but it's not necessary. Root 10, there's your final answer. And again, you can check those on a calculator. I do recommend you give those a check. It doesn't hurt. It's just to verify that you're correct. So now we got to look at when we have a binomial denominator. So binomial denominator is when we have to multiply by what's called the conjugate of the denominator. So it's a pretty neat how this little trick works. So a conjugate is basically binomials have here is 2 terms, and since it's a plus here, the conjugate is a minus, and if it's minus, the conjugate's a plus. So you do the opposite sign between the 2 terms in the binomial, and that will help rationalize your denominator. So you'll notice I have 1 divided by 2 plus root 3. So in order to rationalize the denominator, we got to multiply by 2 root 3, but instead of plus, we put a minus in between the 2 terms. Because what happens is, it's pretty neat, then you're going to see the 2 multiplied by the 2 and gives you 4, obviously. So 2 root 3, 2 multiplied by root 3, plus 2 multiplied by negative root 3, you'll notice that these terms are the opposite sign, so there's where the 0 principle comes from. So you'll notice that is equal to 0, it's eliminated. And then the root 3 times negative root 3 becomes minus root 9, which becomes 3, and the denominator becomes 1. So this final answer of 2 minus the square root of 3 is this part rationalized. Okay, so we don't have we can't have a radical in the denominator. Finished. Okay, this one here is a little more to it, a little more meat to it, but it's not bad. So remember, it's 3 root 2 plus root 3 is the denominator, so we multiply by 3 root 2 minus root 3. Okay, and we just follow all the steps that we learned when multiplying two binomials in the previous video on multiplying radicals, and we just follow through the process, right? So we have 14 times 3 is 42, 6 times 2 is 12. We have 14 is here, so it's multiplied by 1, and then 6 times 3 is 18. Now you can simplify those as well. Same with the denominator. 3 times 3 is 9. Root 2 times root 2 is 4. 3 times, well, it's negative 1, so negative 3. And 2 times 3 is 6. Root 3 times 3 root 2 becomes 3 root 6. There's where that zero principle comes in, that's gone, right? That's the whole idea of the multiplying by the conjugate. It allows you to eliminate the second and third term that you get when you multiply. And then 3 times minus root 3 becomes minus root 9, which is 3. So let's simplify this. So 12 can become 2 root 3, so it's 84 root 3. 18 becomes 9 times 2, which is 3 root 2. Multiply negative 14, you get negative 42, so we get negative 18 root 3 minus 42 root 2 all over 15. Then we got to look for all the coefficients in the denominator. These are divisible by 3, so the 84 divided by 3 is 28. 42 divided by 3 is 14, and 15 divided by 3 is 5. Just like you would simplify when you're using the quadratic formula. And remember, you would simplify your exact value answers. It's the same idea, right? Because there's two terms, and both terms can be divisible by 3, so we divide them by 3 and we just simplify. So there's your final answer for that one. And then I got a couple more examples in example 2 there with rationalizing the denominator. And that's it, really. You can try those on your own. They have some variables involved, doesn't make it any more difficult. Just follow your process. Okay, make sure you multiply your numerator and your denominator by the same binomial, right? Okay, that's rationalize the denominator. If it's minus, you switch it to plus. If it's plus, you switch it to minus, obviously. That's the conjugate. Okay, that's it for 5.2, multiplying and dividing by radicals. There's some questions there. Some multiplying ones and then some that have both involved. Just recommended questions, and that's it. And in the next video we're going to look at 5.3. We're going to start radical equations, start solving those. Okay, so we'll see you in the next video, and thank you very much.